No, he's good with the buttons.
Hey. Is that rain?
It's an explosion. That's the debris.
That's right. All right, here we go. This is exterior angles and the angle triangle sum theorem. These are both theorems. Remember, the word theorems just means like an argument. Okay, a theorem is actually, more specifically, it's like a rule that allows you to make an argument, right? So we're going to look at these two theorems, triangle sum theorem and exterior angle theorem. We're going to use the triangles I already handed out to go ahead and figure all this out. Okay. Let's go ahead and start by reviewing. Oh yeah, forgot. Right. Okay, review. A straight line, the degree measure for a straight line, 80 degrees. Somebody correct me. I meant to say 180 degrees. So if I'm opening up a book, right? What is it right now if I'm opening it up halfway? 90 degrees. Okay, you guys know this easily, right? Super review. 180 degrees is when the book's flat, because it's a straight line, right? If I can make it a straight line. 90 degrees. What do we call an angle that's less than 90 degrees? Down. Acute? Ah, it's cute. It's a cute little angle, right? Easy to remember that. How about if it's more than 90 degrees?
Obtuse.
Obtuse. Okay. So I'm glad you know those angles, kind of definitions already. Basically, I need you to remember this, that a straight line is 80 degrees. And also, just a review on how to label the angle. This angle right here, BAC, the measure of angle BAC. Remember, the middle letter, the middle vertice has to be our vertex. This is the vertex because it's BAC, right? If I said it was CBA, CBA would be different. So those have to be in that order. What else could I say instead of BAC? What's another option that's exactly the same? Exactly the same. It's just labeling it a little different. C, C, A, B. BAC and CAB are talking about the exact same angle. It's just labeling it in a different order. But the middle letter basically has to be our vertex, has to be the angle we're talking about. That's all. Okay, so I'd read this, the measure of angle BAC. That's how I'd say it. All right, now for the activity. I want you all to look at your triangle and look at your neighbors. Is your triangle the same or different than your neighbors? Just peek over to your neighbors, hold up your triangle. What do you think? There's about 7 different kinds of triangles out there. Are they the same? Some might be the same. Okay. So I have my triangle up here. I want you to do the exact same thing that I'm going to do. I want you to, from each of the sides, I want you to rip in towards the center of the triangle. So you see what I did there? I just ripped one side like that. Okay. And then what we're going to do is, right, you're going to rip from the other side towards that center point. You see how I just ripped off one side?
No.
So all I did was rip one side to the center, and then I go to another side, and I rip towards that center point, and I go to another side, and I rip towards that center point. So you should end up with three different shapes here, where the vertices are angles. It's too small. For that one, you could just rip it in half, right through the middle. There you go. Okay, and then in your right hand, rip between the side that was left over right to that middle point again. There it is. Yeah. Give it a little bit of room. Okay. I think that one was the really thin one's the hardest.
I don't want to do it because I don't want to mess up.
You don't want to mess up. All right, guys, then here. That's right. Go ahead and with your marker or wherever, just make a point in the middle. Make a point. Okay? Just make a little point.
I said that earlier.
That's perfect. You got it.
Really? It's perfect?
Yeah.
Aww.
Who needs perfection?
It's mine.
Yours is perfect too.
Yeah. What
All right, so go
He
ahead.
stuttered. He
Go
stuttered.
ahead. From my ribs here. Yes. You messed up? No worries. Well, that's too many ribs. That's a lot of pieces. I have extras, luckily. That's fine. You got it. All right. Piece them back together so it's in a triangle. Piece them all back together so they're in a triangle. And now watch what I'm going to do. Watch what I'm going to do on this line we created. So first we start like this. This is my reformed. How did this go? Like that.
Wow.
This is my triangle, right? Nice. So these are the original vertices of the triangle, right? It's pretty easy to see. All the other sides are ripped. You're not going to get confused on that, right? The ripped side isn't what we're going to use to manipulate here. What we're going to do, and I want you to do this right now on yours, on that line, I want you to put this vertice facing on the inside there. And then we're going to take the other piece, and that vertice that is the perfect vertice here. We're going to put that one like that. Where do you think the last one's going to go? Think it's going to fit?
No.
So I want this vertice to be facing and touching at one point. Watch what we have.
What's happening?
My line's not big enough.
Like this?
Okay. You can use the side of the paper if you want. All right, so this is what I did one more time. I had these pieces like this. This is my triangle. I'll even make a mark. Here are my vertices.
Wow.
Right? You're going to bring all those vertices together on the line. Watch. Here we go. One. The other vertice. They're all touching. Where's the last one go?
Right there.
I want you to do that on your own right now.
It's a crown.
It's a crown. Wow. Oh, I didn't even know I was making a crown. There you go. What are we doing? We had the triangle, we ripped it up. The corner vertices, bringing them all together, what do all those angles create?
180 degrees.
There we go.
Oh!
You see what we just discovered?
That triangle is secretly 180 degrees long.
Oh, well, it's no secret anymore, right?
Oh! Someone called the CIA. Because we busted their plan.
Oh my, special counsel. Here we go. So, what did we just discover? The triangle sum theorem. Angle A plus angle B plus angle C equals what?
180 degrees.
All right, fill it in.
Wow.
That actually, I thought was a pretty good way to teach that. You guys get that?
Now did it work?
It worked, right?
It worked.
Did it work for everyone's triangle? No. Raise your hand if it did not work. Really? Let's see.
I don't think that's a good way. I'm making it.
All right, it did work. All the triangles will work even though they're all different because any triangle you have, the angles, the sum of the angles always adds up to 180. All right. Next. All right, bring it back together. Hold on to the triangles for a second. You already jotted this down. The exterior angle is on the outside. It's on the exterior. If you're painting the exterior of your house, it's on the outside. Interior is on the inside. Okay. What we can figure out is that this angle D is equal to adding two of them together. So watch what I'm going to do. I want you to go ahead and recreate your triangle on that other line. If it's too big, just go over your writing. It's not a big deal. Just make a little dash line if you don't want to write right over your text. But what you're going to do is, I want you to trace out your triangle on this line. Trace it out. Okay, everybody see this? All right, let's call this ABC. Let's put a D over here. What is the name of this angle right here? What is the name of that angle? How do we name off angles again?
Obtuse.
It is obtuse. That is a label based on angle. Perfect. But if I said this is angle what? Angle what? That's what we're going to put here.
BCD.
BCD. Perfect. So the measure of angle BCD is this angle. What we're trying to figure out is angle BCD is equal to what? So watch what I'm going to do. These opposite angles over here, I want you first off to take these opposite ones over here. Okay? And I want you to see if these two angles with the vertices touching each other, if they fit in an angle BCD. Go ahead and manipulate it to see if they fit in BCD. The ones that were furthest away from that C angle, we're going to go and put both of those and see if they fit. If they fit right here at BCD. Go ahead and just move them around, see if it fits.
I just want to make sure the drawing.
All right. Whose angles fit to make that angle, to fit that angle perfectly? Did anybody get that? Yeah? Watch. I took these angles from the opposite side. I'm going to place them in this gap. And what did we just figure out? That this exterior angle is equal to the sum of those opposite angles. So what I can say here is that angle BCD is equal to the measure of angle
BA.
BA is a line segment, so more specific for the angle. BAC. BAC is over here. And then add it to what? What's the last bit?
Not A.
That's an A.
BCD.
Oh, this actually is angle. That's a M, measure of angle. So it's not a less than sign. It's just the angle symbol. Let's see. So we had BAC. What other angle did we move over here? What's this angle? A, B, C. All this is saying is when you have this problem right here, this angle right here is equal to these two angles added together. Equal to, congruent. Okay, that's all we're saying. And we figured that out by just moving them. Because we look at this again, I'm here and I'm here. Right? I take those opposite angles, and what they do is fit perfectly in my exterior angle. See how I do that? Okay. So this is something that creates this relationship. We just figured out that the exterior angle theorem, what it says is that our exterior angle is equal to the opposite side, the opposite angles. So this is our exterior angle, and these are our opposite angles. All right. So now we're going to just use that information right here. This is pretty straightforward. We know that this angle is equal to which other angles? And I'll just say the vertice. So is it the angle that has a vertice A, B, or C? Which ones add up to give us 130? Which ones add up to give us 130? this one, and this one, right? Okay, so if we add this one, and we add this one, it's equal to 130. So I go 130 is equal to 80 plus x. You see why? Because the relationship, we know that the exterior angle is equal to those opposite angles added together.
Wait, why does the opposite angles why can't it be B and C?
Why couldn't it be this and this?
Yeah.
Let's see, watch. So what you're suggesting is that this angle is equal to potentially B and C. Let's see. Does that fit perfect?
No.
Not quite, right? So what we just figured out is that the relationship is always between the exterior angle over here and these two.
Okay.
Yeah? Okay. So we put that there, and we could see, yeah, that's how we get a perfect fit. Okay. So what should I do to solve for x? Last bit. What should I do?
130 subtract 80.
Good. Minus 80, both sides, minus 80, minus 80. 50 is equal to x, 50 degrees. Because that angle B with vertex B is just x degrees, I just put whatever I found for x in there, and that's my answer. You see how the relationship tells us how to do the problem? Because those angles relate in that same way every time. All right, the next one, this is the last bit. And in the homework, this is about as far as it gets. I'll let you know that. We want to find the measure of ABC. ABC. So this one up here we want to find. We're told that this angle up here we're trying to find is equal to x plus 10 degrees. X plus 10 degrees. Don't be intimidated by this. We know that this outside angle is equal to this one plus that one. Right? So watch what I do. 120 is equal to x plus 10 plus 40. Why did I do that?
Why'd you put it in parentheses?
I didn't have to, but I want to show that that's grouped
Okay.
together. Okay. So all I did here was showing that the exterior angle is equal to this angle, x plus 10, plus this angle, 40. That's why I just added those together. Okay. So I go ahead and do a little bit of algebra magic. Plus 50. Minus 50 minus 50. We're going to get x to 70. Now, is that angle equal to 70 degrees, or is that just, I need one more step? What do you guys think? Because look, we're trying to find ABC. ABC is equal to x plus 10. I just solved for x, so what do I need to do lastly?
You need to add
I need to add 10. I look at this, I remember that x plus 10 is equal to that. So I'm going to put in the 70 plus 10 degrees, 80 degrees.
plus 40, it's 120.
That's what we got. See how that works together? Okay.
Crazy.
Isn't it? Did this help to see how the parts fit together? Okay. This is kind of like something that if you forgot these rules, right, you can just cut out a triangle off your test page, rip it up, and figure these rules out again. Okay. Oh, you can borrow a piece of paper and do it. That'll work. Okay, that was the lesson for today, and we have not too much time left, so
Awesome.
thumbs up, sideways, down for this. Good? Okay, it's in the workbook. It's on page 161. So I'll just remind the viewers to get your Oreos, subscribe. I'm 98. Got to break 100 at least. That's it.